Hey there, ladies and gentlemen. Hopefully you did pretty well on that test. I'm pretty confident. You guys are working hard. So let's talk about this consolidation activity because we're introducing you to a little pre-graphing calculator work. And although you don't need a graphing calculator to do this, it gets you thinking kind of in that mode. So it's worthwhile to make sure that you guys are doing really, really well on this. So here's kind of what's happening. So you have this guy Matthew who's throwing a ball into the air, and that the ball being thrown into the air, there's Matthew, is resulting in these heights. Now, you can make a basic observation about these heights that are going to make a lot of sense. If he's throwing this ball and it's going up, it's going to have to come back down at some point, which means it reaches at some point a maximum. And then, of course, it reaches at some point a minimum where he's actually catching with his glove. And it kind of makes sense that it should go up and come back down in the same way this table increases to a max and then decreases back to 7. So the task here is not so much to understand the situation, but it's really just to have a good understanding of how to graph the situation. So what's happening right here is that Matthew made an attempt to graph this data in the table using a graphing calculator. Now, you'll hear us call this several times a default window, and that's because when you reset your calculators and you first turn it on, it's set to this kind of this viewing window. And so let me help you interpret kind of what this means, just so you guys know. X min is the X minimum, and of course, if we know that the x-axis is a horizontal axis, making the y-axis a vertical one, x min refers to the smallest version of x possible. So another way to say that is x min is actually right here at -10. Following that logic, x max, which is set at 10, is going to be the largest possible value of x, which is going to be then a +10 on the right side. And now this scale refers to what you're counting by. So what you can kind of surmise is that each of these little tick marks counts as 1. So that's 1, that's 2, and so on and so forth. I'm not going to put them all out there, but that's what it means. So the y's kind of mean the same thing. So we have a y min set at 10. I'm assuming -10, so it's down here on the bottom part of the bottom part of the y-axis. And then we have a x max at y max, excuse me, at +10. So that's going to be up here. And again, the scale, if you look, we'll have me use that. Let's use gray. Okay, so the scale is going to be counting by 1 every time. Okay? So each of these little tick marks stands for 1. So it's like 1, 2, 3, 4, 5. I'm not going to put them all there. Now, the X-res is something you guys can just kind of ignore for right now. It has to do with a resolution setting. If you play with it, you see some of the effects. You don't want to play with it now. Do it after consolidation. But that's what the pieces mean. So when what's his name, Matthew here, graphed this function using this window, here's all he saw. He saw 2 points. I'm going to try to highlight them in pink. He saw this point. Ooh, boom, boom. He saw this point right here, and that point right there. But that didn't make any sense to Matthew because if you look, he actually saw many points. He actually should have seen 1, 2, 3, 4, 5, 6, but he only saw 3. And the culprit is that you just don't have enough. Your scale is all off. So let's make some basic observations about our table before we actually have to regraph this. If you think about it in terms of the x min, x max, etc., here's the x and here's the y. So in terms of the smallest and largest values of x, looks like the smallest value of x is right here. I'll highlight that in yellow. So there's our smallest value of x. Here's our biggest value of x. That's not very much. So consider this. This table went from, or this graph that he made in his calculator, went from -10 all the way up to 10. But he only had to go from 0 to 1.5. Of course he can't see anything. It's all smushed together. Here's the other part that he's not really being aware of. This had to go from 7 at its min, and there's 2 7s actually, to its max value at 16. But again, if you look at what Matthew did on his graph, it's going from -10, and there are no negatives here at all. The smallest value is 7, to a max value of 10, which isn't even enough to graph his second point. So of course he's not seeing anything. His graph is all messed up. So here's our task. Let's reevaluate this. And there's a version of it really nice. So let's go ahead and reevaluate this table and then graph it nicely down here. So the first thing we definitely have to do is make a axis and scales. But luckily our graph tells us what that's all about. We have a x value, or x thing, that's going to be elapsed time. And then we have a y that's going to be ball height. So if we go down to our axes, the very first thing we should do is record that. This is going to be time in seconds. And then, of course, over here on the left shall be height. Okay, and we could probably be a little more informative. I believe that's in feet. It is in feet, so I'll write in, in feet. Okay. So now we've already kind of figured out some information above, but I'm getting kind of tired of flipping back and forth. So let's record that information below. So the minimum x that we have to graph is going to be is going to be 0. The max x was going to be 1.5. The min y is going to be 7, and the max y is going to be 16. So let's figure this out. If we have this entire axis down here to count by, and we only have to cover from 0 to 1.5, that's going to give us a lot of leeway in terms of what we're going to count by. So here's what I'm going to do. I'm going to count by 0.1. So I'm going to do that for a couple different reasons. One, we don't have to get very far. And two, if you look at all the numbers I have to graph, they're all in increments of 0.1. So if I graph by 0.1, or sorry, I scale by 0.1, I should be good to go. Let's try this out. So that's 0.1, 0.2, 0.3, 0.4, 0.5, 0.6, 0.8, 0.9, 1.0. That's 1.1, 1.2, 1.3, 1.4, 1.5, and that's where I need to get. That's my max. And it looks like I'm covering most of my graph, so we're actually good to go. And that graph went actually all the way to 2. Kind of implying then that my axis itself, my x-axis, is going to be here, which makes a lot of sense since I don't actually have to cover any negatives. In the same way, my y's never drop below negative. In other words, never like go below the ground or below where he's standing. I can use my axis again right here. Let's talk about our y mins. We got to go from 7 to 16. We're already starting at 0 because that's what I have here in my origin. But we have to get to 16. We got a lot of room to do that. We can probably get away with counting by ones here. Let's go ahead and try that out. 1, 2, 4, 6, 7, 8, 9, 10, 13, 14. And there we have all the way to 16, so we should be good to go. Okay, so now it's a matter of pulling in the values and seeing if we can make our graph look like the graph above. Okay, let's take a look here. Okay, so the very first thing I need to graph is this line right here. So we got 0, 0.0, comma 7, so 0, comma 7. Boop. Okay, and then we have 0.3, comma 12. So sorry about that. So 0.3, comma 12. And then we have 0.6, comma 16. Okay, now you guys are good at patterns. It looks like it's going to be symmetric on the way down. Indeed, we have 0.9, comma 16. 1.2, comma 12. And then 1.5, comma 7. Okay. So we have a pretty good facsimile of what that graph looks like above, but now we have it kind of mapped out. So the good lesson to take from this is that even though you're dealing with really, really small numbers, it doesn't mean you can't graph it. We just have to make sure we're spreading it out and covering our whole axes. So that's the consolidation, guys. I do have homework for you, and hopefully a homework vid coming very, very soon. All right, thank you.